Good morning, students. In the second year topic, we will discuss about surface chemistry. The topic is surface chemistry. Here, before the discussion of this topic, in that chemistry based on the materials and characters, it will be major classification is organic chemistry, inorganic chemistry and physical chemistry. Now here we are discussing of surface chemistry. Chemistry means dealing of the compounds and dealing of the molecules and how it will be changes their physical and chemical properties are discussed in the chemistry. So that is known as surface chemistry. In this surface chemistry, what we are chemistry means dealing of the compounds, how the physical and chemical properties are variable. So that is called as chemistry. And that chemistry, before one word is there, surface. What is the meaning of surface? Surface means you can take any object. On that object, the surface means upper layer. Surface means upper layer. Py layer గురించి మాత్రమే డిస్కస్ చేసేటువంటి కెమిస్ట్రీని మనం సర్ఫేస్ కెమిస్ట్రీ అంటాం. సర్ఫేస్ కెమిస్ట్రీ, సర్ఫేస్ మీన్స్ అప్పర్ లేయర్ ఆఫ్ ఎనీ ఆబ్జెక్ట్. The object are either solid or in case are liquid. So here the simple example I am taking of the surface chemistry. If you take any solid material, if the solid material is, for example, this is the duster. This duster is the solid material. The duster upper layer will having the dust particles, means chalk particles are deposited. Chalk particles are deposited. These chalk particles are deposited on the surface area only. These chalk particles are deposited on the surface area only, but not inner layer. And if you take any sponge duster, if you rub on the board sponge duster తీసుకొని బోర్డును రబ్ చేయండి. రబ్ చేస్తే డస్టర్ పైన చాక్ పీస్ పార్టికల్స్ అనేవి పైన మాత్రమే ఉంటాయా, లోపలికి వెళ్ళిపోతాయా అంటే పైన మాత్రమే ఉండిపోవడం జరుగుతుంది. ఇఫ్ ద చాక్ పార్టికల్స్ ఆర్ డిపాజిటెడ్ ఆన్ ఓన్లీ ద సర్ఫేస్ ఏరియా, సో దట్ ఫినామినన్ ఈజ్ కాల్డ్ యాజ్ adsorption. That phenomenon is called as adsorption. The surface chemistry is deals with if any particle. What are the particle? Either gas particles or liquid particles or solid particles. Gas particles, liquid particles or solid particles deposited on surface area. Deposited on surface area. That phenomenon is called as adsorption. That phenomenon is called as adsorption. And these molecules are called as adsorbates. These are called as adsorbates. What are the adsorbates? The adsorbate means the particles. What are the particles? Gas particles or liquid particles, or in case of solid particles deposit on the surface, those molecules, and that phenomenon, that molecule is called as, these molecules are called as adsorbate. And where it will be deposited? On duster it will be. These particles are deposited on duster. So the solid material or in case of liquid material is called as adsorbent. Is called as adsorbent. Adsorbate particles are deposited on adsorbate particles are deposited on adsorbent. Adsorbate particles are deposited on adsorbent. That process is known as adsorption. That process is known as adsorption. Adsorption is what type of phenomena? It's a surface phenomena. Surface means upper layer phenomenon only, not inner layer phenomenon. Now you see that. What is the duster? Now duster is called as adsorbent. What are the dust particles or chalk particles are called as adsorbate materials. So this phenomenon is called as adsorption. This phenomenon is called as adsorption. So this adsorption takes place on the surface area to inner layer, that is up to 100 nanometers depth it will be takes place. How much means 100 nanometers depth it will be takes place. Now this adsorption phenomenon, now I am telling the simplified example of the duster. Now we go for different type of chemical compounds. As you know very well, in that reduction of organic compounds, that is known as hydrogenation of oils. Hydrogenation of oils means, I think in the first year level one reaction is there, ethylene CH2 double bond CH2. This is known as ethylene molecule. Ethylene is called CH2 double bond CH2 ethylene. This ethylene undergo the hydrogenation. Hydrogenation means we are adding hydrogen. Hydrogen is gas. Gas directly it will be reacted? No. So we have to accumulate that hydrogen gas on any of the surface. Which surface we are using? That hydrogen present in the presence of nickel or palladium or platinum. Means the nickel plate it will be there. That nickel plate is a solid plate. That solid plate will having that whatever the interstitial spaces are present. Interstitial places. Interstitial places means what about the empty spaces on the solid surface. Empty spaces on the solid surface. How it will be created? The solid material, one cation and one anion or different type of particles are accumulated or combined together to form a unit like structure. It is a solid structure. In this solid structure, the interstitial places, what about the gaps will be present. So that gaps, this hydrogen gas is deposited, that is called accumulation. That is known as accumulation. So after the deposition of the hydrogen gas on the solid surface of nickel or palladium or platinum, here hydrogenation takes place. Now the pi bond will be eliminated, that hydrogen gas is deposited. Now this hydrogen gas will be deposited on the solid surface. Now here nickel, palladium, platinum. Nickel, palladium, platinum, that is the solid surface. It is called as nickel, palladium, platinum, it is called as adsorbent. The gas, hydrogen gas deposit on the nickel, that is called as adsorbate. So now we can observe. This is the duster will have the chalk particles are present. If I am applying some force, is the dust particles are again stick on the surface or it will be eliminated? Of course, if you are applying the force like this, if you are applying the force, automatically the dust particles are erased out. Dust particles are erased out. If you are applying the force on the surface, automatically the dust particles are escaped from the surface. So if you are applying the force, the particles are escaped and particles are ejected. So is that perfect attraction force is there from adsorbent and adsorptant? అంటే నేను ఫోర్స్ అప్లై చేయగానే చాక్ పార్టికల్స్ అన్నీ ఏమైనా ఇక్కడ నుండి ఎజెక్ట్ కావడం జరిగినాయి, కింద పడిపోవడం జరుగుతున్నాయి. అంటే చాక్ పీస్ పార్టికల్స్కును డస్టర్కు స్ట్రాంగ్ అట్రాక్షన్ ఫోర్స్ ఉందా, వీక్ అట్రాక్షన్ ఫోర్స్ ఉందా? ఎలిమినేట్ ఇట్లా ఫోర్స్ అప్లై చేయగానే కింద పడిపోతున్నాయి అంటే మీనింగ్ ఏంటి? అడ్సార్బెంట్కును అడ్సార్బేట్కు అట్రాక్షన్ ఫోర్సెస్ విల్ బి లెస్. సో what about this here? That is called as weak attraction forces. Molecular attraction forces lo weak attraction forces ni explain chesina scientist evaru ante van der Waal. So the weak van der Waal forces are present. So adsorption, once again, adsorption is what type of phenomena? Is a surface phenomena. Adsorption takes place on the surface. What are the surface materials? Surface materials ఏంటి అవి? either solid కావచ్చు లేదా liquid కావచ్చు. ఆ సర్ఫేస్ మెటీరియల్ మనం కెమిస్ట్రీలో ఏమైనా ప్రొనౌన్స్ చేయాలి? అడ్సార్బెంట్. అడ్సార్బెంట్ పైన డిపాజిట్ అయ్యేటువంటి పార్టికల్స్ ఎవరు? గ్యాసెస్ కావచ్చు. లిక్విడ్స్ కావచ్చు లేదా సాలిడ్స్ కావచ్చు. వాటిని మనం ఏమని ప్రొనౌన్స్ చేస్తాం? అడ్జార్బేట్. అడ్జార్బేట్ పార్టికల్స్ వచ్చి ఎక్కడ డిపాజిట్ అయితే అడ్జార్బెంట్ పైన డిపాజిట్ అవుతాయి. అడ్జార్బెంట్ పైన డిపాజిట్ అవుతుంది కనుక ఆ ప్రాసెస్ను మనం ఏమంటాం? అడ్జార్ప్షన్ అంటున్నాం. దాన్ని ఏమంటున్నాం మనం? అడ్జార్ప్షన్. దానికోసం చాక్ పీస్ను ఇంతకుముందు ఎగ్జాంపుల్, దానికి కెమికల్ ఎగ్జాంపుల్ ఏం తీసుకున్నాం మనం? ఇథిలీన్, హైడ్రోజనేషన్ ఆఫ్ ఆయిల్స్. సో దట్ ఈస్ హైడ్రోజన్ గ్యాస్ deposited or accumulated on solid surface. What are the solid surface material? Either nickel material or palladium material or platinum material. And another one is activated charcoal. Charcoal means, you know very well, coal means bogu. Charcoal means powdered form is called charcoal. Activated charcoal, one another word is also there. Charcoal and activated charcoal. Activated means if you are taking a finely powdered mixture of the coal material is the activated condition. Activated condition means you are heat the material. హీట్ చేసినప్పుడు కోల్ని హీట్ చేసామనుకోండి, దాంట్లో ఏమైనా మాయిశ్చర్ ఉంటే ఏమవుతుంది? ఎలిమినేట్ కావడం జరుగుతుంది. మాయిశ్చర్ ఎలిమినేట్ అయిందనుకోండి, కోల్ అంతా కూడా ఏమైతే పోరస్ అయిపోతుంది. పోరస్ అంటే హోల్స్తో పర్ఫెక్ట్గా ఉంటుంది. అప్పుడు ఏమవుతుంది? రిమైనింగ్ గ్యాసెస్ని ఈజీగా అబ్జర్వ్ చేసుకునేటువంటి కెపాసిటీ ఉండడం జరుగుతుంది. సో చార్కోల్ ఈజ్ ద కోల్ మెటీరియల్. యాక్టివేటెడ్ చార్కోల్, యాక్టివేటెడ్ మీన్స్ ఇఫ్ యూ ఆర్ హీట్ ద కోల్ మెటీరియల్ above 300 degrees centigrade like that, in that coal material is there any moisture is present? కోల్లో ఏమైనా మాయిశ్చర్ కనుక ఉంటే అది ఏమవుతుంది? ఎవాపరేట్ కావడం జరుగుతుంది. ఎవాపరేట్ అయినప్పుడు ఏమైతే? ప్యూర్ డ్రై ఫామ్లో చార్కోల్ ఉంటుంది. ప్యూర్ డ్రై ఫామ్లో ఉన్నప్పుడు అది పర్ఫెక్ట్ అడ్జార్బెంట్గా పనిచేస్తుంది. వెన్ ఇట్ విల్ బి యాక్ట్ యాజ్ పర్ఫెక్ట్ అడ్జార్బెంట్, that adsorption phenomena will be enhanced. That is called as activated charcoal. And another one is in the preparation of sugar preparation, we have to take place from the cane juice, molasses. In that molasses, decolorization is also what type of phenomena? Is adsorption phenomena. If we take several gases in the closed container, this is the container. In this container, I am taking charcoal material here. I am taking charcoal material. This container is, what about this closed container? In this closed container here, oxygen gas, nitrogen gas, different carbon dioxide gases are present. When I am placing that charcoal or activated charcoal, here before that some X amount of pressure it will be present. The container is filled with different type of gases. That gases will have some amount of pressure it will be there. Some X amount of pressure will be there. Now what I am doing, I am placing here charcoal. After 1 hour or in case of 2 hours, what happened? The pressure will be reduced or pressure will be decreased. Why pressure will be decreased? The gas particles are deposited on the surface of the charcoal. When gas particles are deposited on the surface of the charcoal, automatically pressure will be reduced. That phenomenon is called as adsorption phenomenon. And another one is different type of coloring dyes will be there. Coloring material, methylene blue this material is used for what about the printing of the cloth materials. Kalankari, khadi, like this type of cloths, they are printing the different type of what about the designs. And that phenomenon is also what type of phenomena? Adsorption phenomena. So like this, what over the adsorption phenomenon it will be takes place. That is adsorption and adsorbate and adsorbent molecules. So here adsorption process, what about in the dry condition, it will be having more, it will be takes place if some of the gases will having the readily liquefiable gases will be there, carbon dioxide gases, oxygen, nitrogen, those gases will be deposited on the surface material. Now here another one is, these are the two carefully observed point, adsorbent and adsorbate. Now coming to that absorption. Now another one is absorption. If you carefully observe, this word is adsorption, this word is absorption. Now what I am here before explaining, adsorption is surface phenomena. Absorption is bulk phenomena. Bulk phenomena means it will be enter into the inner body of the material. How it will be means, I will give a simple example here. Now take one sponge duster. Now that sponge duster, what you have to do? Just place it into the water tub. ఒక వాటర్ టబ్లో ఈ స్పాంజ్ డస్టర్ని వేసేయండి. అదేమవుతుంది, వాటర్ని అబ్జర్వ్ చేస్తూ సింక్ అయిపోవడం జరుగుతుంది. ఇప్పుడు చెప్పండి, వాటర్ ఓన్లీ సర్ఫేస్ పైనే ఉందా స్పాంజిలో, వాటర్ మొత్తం ఇన్నర్ బాడీకి వెళ్ళిపోవడం జరిగిందా? when we are observing sponge, just that sponge we are placed into the water. స్పాంజ్ని తీసుకుపోయి ఏం చేశాను, వాటర్ టబ్లో పెట్టేశాను. వాటర్ టబ్లో పెట్టేయగానే వాటర్ మొత్తము స్పాంజ్ అబ్జర్వ్ చేసుకుంటుందా లేదా? ఎస్, ఇట్ విల్ బి అబ్జర్వ్డ్. వాటర్ అనేది స్పాంజ్ లోపల ఈ మొత్తం వెళ్ళిపోయింది కదంటే ఇట్ విల్ బి ఎంటర్స్ ఇన్ ద ఇన్నర్ బాడీ. వెన్ ఇట్ విల్ బి ఎంటర్స్ ఇన్ ద ఇన్నర్ బాడీ, that phenomenon is called absorption. That phenomenon is called absorption. Only it will be present on the surface area only. It's called as adsorption. Surface phenomenon is called adsorption. Inner body of the material is absorption. So absorption is what type of phenomena? Is a bulk phenomena. Adsorption, what type of forces will be there? Weak van der Waals forces will be there. In that absorption, if you, what about this? Squeeze the is that water will be directly escaped from the sponge? No, we have to squeeze it. దాన్ని ఏం చేయాలి, ఇట్లా పిండేసేయాలి, స్క్వీజ్ చేయాలి. స్క్వీజ్ చేసినప్పుడు మాత్రమే వాటర్ అందులో నుండి బయటికి రావడం జరుగుతుంది. సో వాటర్ కంప్లీట్గా అందులో నుండి బయటికి రావాలంటే ఏం చేయాలి? వీ హ్యావ్ టు స్క్వీజ్ ఇట్. స్క్వీజ్ చేస్తున్నామంటే స్ట్రాంగ్ ఫోర్సెస్ ఉందా లేదా? ఎస్, ఇట్ విల్ బి స్ట్రాంగ్ ఫోర్సెస్. సో అబ్జార్ప్షన్ ఈజ్ అ బల్క్ ఫినామినా. ఇట్స్ హ్యావింగ్ స్ట్రాంగ్ అట్రాక్షన్ forces will be there. And another one is air becomes dry in the presence of silica. For example, if you any container will having the moisture content is there. The best example is you can take chalk piece. Now if you place this chalk piece, if you take this chalk piece and place into the, what about this, out of the area. Out of the area means room temperature and baita petteseyandi. Now you can observe one day completely of this atmosphere. మార్నింగ్ చూసే వరకు చాక్ పీస్ డ్రైగా ఉంటుందా, కొంత వెట్గా ఉంటుందా? అఫ్ కోర్స్ ఇట్ విల్ బి వెట్. ఎందుకు వెట్గా ఉంటుంది? అట్మాస్ఫియర్లో ఉన్న మాయిశ్చర్ని ఏం చేసింది, చాక్ పీస్ అబ్జర్వ్ చేసింది. అట్మాస్ఫియర్లో ఉన్న మాయిశ్చర్ని చాక్ పీస్ అబ్జర్వ్ చేసింది కనుక ఇట్ విల్ బి వెట్. దిస్ ఫినామినన్ ఈజ్ ఆల్సో వాట్ టైప్ ఆఫ్ దిస్? Adsorption phenomena. So based on this thing, silica gel means silicon dioxide material. So that atmosphere gases or atmosphere moisture is also toward this absorb the system. Now absorption phenomenon is what type of system? Inner body of the system. Next, if you take a colored solution, means either blue color solution or in case of pink color solution, you can have to prepare one colored solution. కలర్డ్ సొల్యూషన్ ప్రిపేర్ చేసి ఇదే చాక్ పీస్ని అందులో వేసేయండి. కలర్డ్ సొల్యూషన్ ప్రిపేర్ చేసి జస్ట్ ప్లేస్డ్ దిస్ చాక్ పీస్ ఆన్ ద కలర్ సొల్యూషన్, డిప్ ఇన్, లీవ్ ఫర్ 2 hours or 3 hours, 4 hours. ఆఫ్టర్ దట్ యూ రిమూవ్ ద చాక్ పీస్. తర్వాత చాక్ పీస్ని బయటికి తీయండి. మీరు ఏ కలర్లో యాడ్ చేశారో ఆ కలరే ఉంటుందా, లేకుంటే మళ్ళీ వైట్ కలర్లోనే ఉంటుందా చాక్ పీస్? ఇఫ్ కలర్ చేంజ్ ఆర్ నాట్? ఎస్, ఇట్ విల్ బి కలర్ చేంజ్. కలర్ చేంజ్ అవుతుంది అని అంటే అర్థం ఏంటిది? మెటీరియల్ అనేది అబ్జార్బ్ చేసుకోవడం జరిగింది. మెటీరియల్ ఏం చేసింది? అబ్జార్బ్ చేసుకుంది. అబ్జార్ప్షన్ చేసుకుంది కనుక ఇప్పుడు మీరు ఈ చాక్ పీస్ మొత్తం ఏ కండిషన్లో ఉంటుంది? వెట్ కండిషన్లో ఉంటుంది. అంటే పార్టికల్స్ మొత్తం, కలర్డ్ పార్టికల్స్, వాటర్ పార్టికల్స్ అన్నీ కూడా ఏమైపోయినాయి? ఇన్నర్ బాడీలోకి ఎంటర్ అయిపోయినాయి. ఎప్పుడైతే ఇన్నర్ బాడీలోకి ఎంటర్ అయిపోయిందో ఆ ఫినామినన్ మనం ఏ ఫినామినన్ అంటే అబ్జార్ప్షన్ ఫినామినన్. అడ్సార్ప్షన్ ఈజ్ సర్ఫేస్ ఫినామినా, అబ్జార్ప్షన్ ఈజ్ ఇన్నర్ ఫినామినా. నౌ here another term is also takes place, that is called as sorption. Now we can see that one is adsorption, another one is absorption, and another one is adsorption, absorption and sorption. Sorption means adsorption and absorption takes place simultaneously, it's called as sorption. Now, that phenomenon means, sorption phenomenon is, you can take any object. If you take object means, for example, if you take duster again. Duster if you place it on the surface of the water surface paina duster nu place chestam. Water surface paina duster place cheyagane surface paina unnatuvanti water molecules em chestayi? First డస్టర్ పైకి డిపాజిట్ అవుతాయి. అంటే ఫస్ట్ ఎక్కడికి డిపాజిట్ అవుతున్నాయి? డస్టర్ పైనకు డిపాజిట్ అవుతున్నాయి. డిపాజిట్ అయిన తర్వాత ఆ ఫోర్స్ ఆఫ్ అట్రాక్షన్తో ఏమవుతుంది? అప్పర్ లేయర్లో ఉన్న వాటర్ పార్టికల్స్ డస్టర్ లోపలికి వెళ్ళిపోయినాయి. అంటే ఫస్ట్ ఏం జరుగుతుంది, అడ్జార్ప్షన్ జరుగుతుంది. మంచిగా వినండి, డస్టర్ని తీసుకొని ఎక్కడ పెట్టేసాం, వాటర్లో పెట్టేసినాను. డైరెక్ట్ వాటర్ పైన పెట్టేసి, నేను డిప్ చేయలేదు, వాటర్ పైన పెట్టేశాను. డస్టర్ని తీసుకుపోయి వాటర్ పైన పెట్టేయగానే ఫస్ట్ ఏమవుతుంది, ఎక్కడైతే వాటర్ టచ్ అవుతుందో, టచ్ అయింది అంటే అర్థమైంది సర్ఫేస్ ఏరియాని టచ్ అయింది. సర్ఫేస్ ఏరియాని టచ్ కాగానే వాటర్ యొక్క ఫస్ట్ లేయర్, వాటర్లో ఉన్న ఫస్ట్ లేయర్ అది ఎందులోకి వెళ్ళిపోయింది, డస్టర్లోకి వెళ్ళిపోయింది. డస్టర్లోకి వెళ్ళిపోయిన తర్వాత సెకండ్ లేయర్ వచ్చి మళ్ళీ డస్టర్. అంటే ఫస్ట్ ఏం జరుగుతుంది, అడ్జార్ప్షన్ జరుగుతుంది. అడ్జార్ప్షన్ జరిగిన తర్వాతనే మనకి ఏం జరుగుతుంది, అబ్జార్ప్షన్ అవుతుంది. అంటే అడ్జార్ప్షన్ వయా అబ్జార్ప్షన్ జరుగుతుంటే ఆ ప్రాసెస్ ఏం ప్రాసెస్ అంటాం అంటే మనం సార్ప్షన్ అని చెప్పడం జరుగుతుంది. ఫర్ ఎగ్జాంపుల్ దిస్ ఈజ్ ద ఆబ్జెక్ట్, ఇది ఒక ఆబ్జెక్ట్, అది డస్టరే కానీ ఇంకేదైనా ఇది ఒక ఆబ్జెక్ట్ ఉంది అనుకోండి. ఈ ఆబ్జెక్ట్ పైకి నేను ఏం చేశానంటే, ఈ ఆబ్జెక్ట్లోకి ఏం చేశాను, డిఫరెంట్ టైప్ ఆఫ్ మెటీరియల్స్ నేను దానిలో డిప్ చేయడం జరిగింది. ఇవి ఫస్ట్ ఆ పార్టికల్స్ ఏమవుతాయి, ఈ సర్ఫేస్ పైన డిపాజిట్ కావడం జరిగింది. ఇట్లా సర్ఫేస్ పైన ఏమైంది, ఇట్లా డిపాజిట్ అయింది. ఫస్ట్ స్టెప్ అంటే సర్ఫేస్ పైన డిపాజిట్ అయిందంటే ఆ ప్రాసెస్ని ఏమంటాం, అడ్జార్ప్షన్. ఇది ఒక ఆబ్జెక్ట్, అది డస్టరే కావచ్చు, ఇంకేదైనా కావచ్చు, వాట్ ఎవర్ ఇట్ మే బి, ఎనీ సాలిడ్ మెటీరియల్. ఫస్ట్ ఏం జరుగుతాయి, ఫస్ట్ స్టెప్లో ఏం జరుగుతుంది, దాని యొక్క సర్ఫేస్ ఏరియా పైన పార్టికల్స్ డిపాజిట్ అయిపోయినాయి. డిపాజిట్ అయిన తర్వాత ఈ పార్టికల్స్ ఏమవుతున్నాయి, ఇందులోకి వచ్చేస్తున్నాయి. ఇట్లా ఈ పార్టికల్స్ అన్నీ కూడా ఏమైనా ఇన్నర్ బాడీలోకి వచ్చేస్తున్నాయి. ఇట్లా ఇన్ ద పార్టికల్స్ ఆర్ ఎంటర్స్ ఇన్ టు ద ఇన్నర్ బాడీ. ఇవి లోపలికి రాగానే ఇదంతా కూడా అవుటర్ సర్ఫేస్ కదా. మళ్ళీ దీని తర్వాత ఇంకొక లేయర్ ఉంటుంది కదా, ఇట్లా అనదర్ లేయర్ ఈజ్ ఆల్సో దేర్. దీస్ ఆర్ ద డిఫరెంట్ టైప్ ఆఫ్ పార్టికల్స్. ఈ అప్పర్ లేయర్లో ఉన్న పార్టికల్స్ లోపలికి వచ్చేసాయి. ఇది లోపలికి రాగానే ఇది ఏం సెకండ్ లేయర్ ఉన్నది కాస్త ఏమైతే ఫస్ట్ లేయర్. అంటే ఫస్ట్ ఏముంది, అడ్జార్ప్షన్ అయిన మాలిక్యూల్కి లోపలికి వచ్చేసినాయి. తర్వాత సెకండ్ లేయర్లో ఉన్న మాలిక్యూల్ మళ్ళీ అడ్జార్ప్షన్ అయింది, అవి ఆ తర్వాత వస్తాయి. మళ్ళీ థర్డ్ లేయర్లో ఉన్న మాలిక్యూల్ మళ్ళీ అవి లోపలికి వస్తాయి. అంటే ఫస్ట్ జరిగేది ఏం జరుగుతుంది, మనకు అడ్జార్ప్షన్ జరుగుతుంది. అడ్జార్ప్షన్ అయిన తర్వాత మనకి ఏమైపోతుంది అని అంటే మెటీరియల్స్ అనేది లోపలికి వెళ్ళిపోవడం జరుగుతుంది. అంటే వాట్ హ్యాపెన్, బోత్ అడ్జార్ప్షన్ అండ్ అబ్జార్ప్షన్ takes place simultaneously. That process is called sorption. This concept is proposed by McBain. This concept is proposed by the scientist is McBain. Scientist is proposed by this concept is sorption. Next, another phenomenon that is called as desorption. That is known as desorption. Now see that first of all, the phenomenon is surface phenomena. Surface phenomena depends on adsorption, and after that adsorption, if particles are enters in their body, that is absorption. In that surface phenomena, what are the particles are deposited? Those particles are called as adsorptor. How much depth it will be takes place? 100 nanometer depth. And deposited molecule, where it will be deposited? Either solid material or liquid material will be deposited, and that material are called adsorbent. If the particles are enters into the inner body of adsorbent, it's called absorption. And that absorption phenomena, how it will be takes place? First adsorption is takes place, then only absorption will be takes place, and adsorption and absorption takes place simultaneously. So that process is called as sorption. That sorption concept proposed by McBain. Next one is desorption. Now you see that in that name is also there, desorption. D means removal. Desorption means we have to remove the particles. We have to remove the particles from the surface area. We have to remove the particles from the surface area. It's called as desorption. Remove the particles on surface area, it's called as desorption. Which particles? Either gas particles or liquid particles or solid particles we have to remove on the surface area, it's called as desorption. Means adsorbed particles are eliminated on the surface area, that phenomenon is called as desorption. So these desorption phenomena, how it will be takes place? Generally you know very well. The desorption phenomena, how it will be takes place? How it will be means, one is temperature factor is there, another one is pressure factor. For example, liquid materials or in case of solid materials are present on the surface area. Liquid కానీ solid కానీ surface area పైన ఉంది అనుకుందాం. దాన్ని ఏం చేస్తున్నాను, నేను హీట్ చేస్తున్నాను. హీట్ చేసినప్పుడు ఏమవుతుంది అంటే మాలిక్యూల్స్ యొక్క కైనెటిక్ ఎనర్జీ డెవలప్ అవుతుంది. మాలిక్యూల్ మధ్యలో కైనెటిక్ ఎనర్జీ జనరేట్ అయ్యి ఆ మాలిక్యూల్స్ ఏమవుతాయి అంటే సర్ఫేస్ ఏరియా నుండి ఎజెక్ట్ కావడం జరుగుతాయి. అంటే మీన్స్ ఎవాపరేట్ కావడం జరిగిపోతాయి. ఆ ప్రాసెస్ని ఏమంటాం మనం, డిజార్ప్షన్. ఇఫ్ యూ ఆర్ యూజింగ్ at the high temperature on condition, what happen, desorption phenomenon is takes place. What is the desorption? Removal of the particles. What particles? Either gas particles or liquid particles or solid particles from the surface area. Surface area పైనుండి పార్టికల్స్ తీసేసేటువంటి ప్రాసెస్ను మనం ఏమంటామంటే డిజార్ప్షన్ అని చెప్పడం జరుగుతుంది. దీంట్లో బెస్ట్ ఎగ్జాంపుల్ డిజార్ప్షన్ను ఇన్ఫ్లుయెన్స్ చేసేటువంటి ఫినామినన్స్ ఏంటి, వన్ ఈజ్ టెంపరేచర్ ఫ్యాక్టర్, ఐదర్ లిక్విడ్ మెటీరియల్స్ ఆర్ సాలిడ్ మెటీరియల్. గ్యాసెస్ మెటీరియల్ మరి ఎవరిని తీసుకోవాలి అంటే ప్రెషర్. ఇఫ్ యు ఆర్ క్రియేటింగ్ ద ప్రెషర్, ద మాలిక్యూల్స్ ఆర్ క్లోజర్ టు ఈచ్ అదర్, ఇట్ విల్ బి ఎజెక్టెడ్ అవుట్. సో గ్యాస్ సాలిడ్ సర్ఫేస్ పైన పార్టికల్స్ డిపాజిట్ అయి ఉన్నాయి. నేను ప్రెజర్ని క్రియేట్ చేస్తున్నాను కూడా, ప్రెజర్ని క్రియేట్ చేస్తే మాలిక్యూల్స్ ఏమైతే సర్టెన్ లిమిట్ వరకు దగ్గరికి క్లోజ్గా రావడం జరుగుతాయి, ఆ తర్వాత ఏమైపోతే ఎజెక్ట్ కావడం జరుగుతాయి. సో దట్ ఫినామినన్ ఈజ్ నోన్ యాజ్ డిజార్ప్షన్ ఫినామినన్. అండ్ హియర్ ద అబ్జార్ప్షన్ విల్ హ్యావింగ్ ద టూ టైప్స్ ఆఫ్ ఫినామినన్స్ ఆర్ టేక్స్ ప్లేస్. What are the two types of phenomenon? One is positive adsorption, another one is negative adsorption. Positive adsorption means that is more particles are deposited on the surface area, it's called as positive adsorption. Positive adsorption is what type of process? It's a endothermic or exothermic, generally exothermic process it will be takes place. The adsorption phenomena are two types. One is positive adsorption and negative. Positive means more particles are deposited on the surface area, it's called as positive adsorption. If the particles deposition rate will be less, it's called as negative adsorption. So that is exothermic process it will be takes place. Now this adsorption based on the mechanism and based on the classification, this adsorption phenomenon is classified by two types. One is physical adsorption, another one is chemical adsorption. Now if you are observing that physical adsorption and chemical adsorption, now carefully observe. Now that adsorption phenomenon will having the classification is, whatever the two types of classification will be there. One classification belongs to, one is property, another one is physical adsorption, another one is chemical adsorption. The first phenomenon is called as, one is nature of adsorption. What is the nature of adsorption? The nature of adsorption is two types of nature of adsorption will be there. One is physical adsorption, another one is chemical adsorption. What is the physical? Physical means the adsorbent and adsorbate molecules, the attraction forces will be less. So that is called weak van der Waals forces is there, that is called physical adsorption. That adsorbent and adsorbate molecules, the attraction forces are, strong attraction forces are there, means strong attraction forces will be there. The type of adsorption is called as chemical adsorption. The chemical adsorption best example is, for example, rusting of iron. If you take ferrous converted to ferric condition, ferrous means Fe plus 2 ion, Fe plus 2 ions are converted to Fe plus 3. If you are observing that ferrous materials are converted to ferric condition, ferrous oxide converted to ferric oxide condition, the rust formation means the oxide materials are penetrate into the inner body of the material. Penetrate means deposited or whatever the absorbed on the surface area, it's a chemical bond it will be takes place. Due to the strong attraction forces, the rust cannot be eliminated that much of easily. By using salt paper only we can eliminate. How its color? It's a brownish color it will be takes place. The brownish color material is called ferric. Ferrous converted to ferric. So that is strong attraction forces it will be there. The type of adsorption is called as chemical adsorption, means due to the chemical forces. Next, enthalpy of adsorption. Here enthalpy of adsorption means on the adsorption phenomena will having that some amount of energy will be liberated. Enthalpy we are representing sign is delta H, and another one is entropy phenomenon. Here enthalpy means after the deposition of the material on the surface area, some amount of energy will be liberated, that is an exothermic process. So, in the physical adsorption, less amount of means low enthalpy it will be takes place. Why low enthalpy? Because of adsorbent adsorbate, the attraction forces will be less. When attraction forces will be less, automatically energy is also less. Energy we can utilizing the chemical terminology is enthalpy, that is delta H, that is only 20 to 40 kilocalories per mole it will be takes place. Whereas chemical adsorption, it is a strong attraction forces will be there, chemical forces is also involving that. So, that more amount of energy is required for dissociate the molecules on the surface area. So, it will be around 80 to 240 kilocalories per mole of energy will be liberated. Means physical adsorption is low amount of enthalpy it will be takes place, whereas chemical adsorption is high amount of energy will be takes place. Another one is reversibility condition. Reversibility condition means physical adsorption is having less attraction forces will be there. Physical adsorption will having whatever the adsorbent and adsorbate will having the weak attraction force is there. So, due to that reason we can again and again we can utilize, means it is a reversible phenomenon. So, how it will be reversible phenomena means I will give the simple example. Take the duster and rub it. After the rubbing of the duster, the dust particles are deposited on the surface area. Surface area పైన ఏం డిపాజిట్ అవుతాయి, డస్ట్ పార్టికల్. దాన్ని ఏం చేస్తాం, ఫోర్స్ అప్లై చేసి వీ హ్యావ్ టు రిమూవ్ ద డస్ట్ పార్టికల్స్. అగైన్ వీఆర్ యూజింగ్ ద డస్టర్, అగైన్ యూ ఆర్ రిమూవింగ్. మీన్స్ ఇఫ్ యూ ఆర్ అప్లయింగ్ ద ఫోర్స్, ద సర్ఫేస్ ఏరియా పార్టికల్స్ ఆర్ ఎలిమినేటెడ్ అవుట్. అగైన్ and again we have to use. Means physical adsorption is reversible process. Whereas chemical adsorption, once the material is deposited on the surface area, once the material is deposited on the surface area, there is a bond in between adsorbent and adsorbate. Adsorbent కు adsorbate కు మధ్యలో ఏమవుతుంది, ఒక perfect bonding phenomenon will be takes place. Due to the perfect bonding phenomenon, whatever the its strength will be more. We cannot remove the material, so that is the reason chemical adsorption is irreversible. Physical adsorption is reversible. Reversible means we have to remove the surface particles and again we have to utilize the surface area. అట్లా కనుక యూజ్ చేస్తే దాన్ని మనం ఏమంటున్నామంటే ఫిజికల్ అడ్సార్ప్షన్ ఏమని ఫినామినన్ యూజ్ చేస్తాం, రివర్సబుల్ ఫినామినన్ విల్ బి టేక్స్ ప్లేస్ ఆన్ ద ఫిజికల్ అడ్సార్ప్షన్. ఎందుకు రివర్సబుల్ వచ్చింది, మళ్ళీ ఆన్సర్ ఏంటిది, లో అట్రాక్షన్. లో అట్రాక్షన్ ఫోర్స్ ఎందుకు, ఎనర్జీ విల్ బి లెస్. Chemical adsorption is a strong attraction force will be takes place in between what about the adsorbent and adsorbate. So, due to that reason it is a irreversible phenomenon. Physical adsorption is reversible, chemical adsorption is irreversible phenomenon, it will be takes place. And another one is temperature and adsorption is more pronounced. So, low temperature will having the physical adsorption, high temperature is required in the chemical adsorption. Boiling point of the adsorption of gases, here low temperature is required, there high temperature is required. Simple phenomena, because of on the surface area the molecules of molecular attractions are less in the physical adsorption, whereas in the chemical adsorption molecular attractions are more in the chemical adsorption. So, to remove the molecules, low amount of temperature is required in the physical adsorption, high amount of temperature is required in the chemical adsorption. First point is physical adsorption and chemical adsorption. Physical adsorption is weak forces, chemical adsorption is strong forces. Physical adsorption will have the low amount of enthalpy, chemical adsorption having the high amount of enthalpy. Next, physical adsorption is reversible process and chemical adsorption is irreversible process. And here physical adsorption is low temperature is required and chemical adsorption is high temperature is required. Next, another one is effect of change in the temperature decreases with rise in the temperature, increases with the rise in the temperature. Physical adsorption will be decreases when if temperature will be increases. If you are increasing the temperature, the adsorbed molecules are erased out. ఇంతకుముందే చెప్పాను, adsorption influence చేసే ఫ్యాక్టర్స్ ఏంటి, టెంపరేచర్ అండ్ ప్రెజర్. If you are increasing the temperature, solid or liquid particles are erased out or escaped out, and if you are applying the pressure, the molecules are closer to each other. Now, so here temperature effect, physical adsorption, if you are increasing the temperature, adsorption will be decreases, and the chemical adsorption it will be increases, because of by using the temperature the molecular extensions are increases. So, due to that reason perfect bonding capacity is increases. So, by using the temperature, physical adsorption is decreases, chemical adsorption will be increases. Next, specificity of adsorption, not specific generalization it will be takes place, it will be takes place on all the surface area, highly specific takes place on specified surface only. Now, for example, the specificity means on that particular materials only it will be developed. For example, I am telling a simple example in the earlier. Hydrogen is deposited on nickel or palladium or platinum. So, that is the reason it is called specificity. By using the specificity on the internal surface or what about the materials or interstitial spaces will be perfect is there, then only the gas materials are deposited, otherwise it will not be deposited. So, whereas physical adsorption it will be deposited, there is no specificity, it will be takes place like dust particles are deposited on the surface area. Next, another one is nature of the adsorbents and layers are formed. Here, nature of the adsorbent and layers phenomena. Here, nature of the adsorbents means in the physical adsorption, if you take the best example, you can take again the duster. Now, we are once rubbing the duster, the dust particles are deposited on surface area. Again you are rubbing, again the dust particles are deposited, again the dust particles are deposited. So, now this physical adsorption is what type of system? Is a multi-layered system. Physical adsorption is what type of system? It is a multi-layered system, whereas chemical adsorption is only single layered system. Means how it will be multi-layered? For example, this is the object. In this object, first of all the particles are deposited on the surface. Again, if you are again utilizing that material, again the particles will be deposited, again the particles will be deposited, again the particles will be deposited. Because of weak attraction force, due to that reason the particles are deposited on the surface area. So, physical adsorption is multi-layered system. Now, if you take the object, if the materials are deposited on the surface area, if the materials are deposited on the surface area, is a perfect bonding or perfect attraction force takes place between the adsorbent and adsorbate. So, due to that reason it is a single layered system, it is a single, but whereas physical adsorption is it is a multi layered system, chemical adsorption is single layered system. Next one, energy of activation. Insignificant is a very low amount of energy. Here we have to utilize high amount of energy, it will be required, and easy of desorption. We can remove the materials on the surface area, we can easily remove the materials from the surface area in the physical adsorption, whereas in the chemical adsorption to remove the material more amount of energy is required. So, in this adsorption phenomena, in the delta H is equal to negative as well as delta S is equal to also negative. Delta H is negative, delta S. H belongs to enthalpy. The systematic approach of the energy changes is called enthalpy, and random motion or random molecules, the energy, what about the variations we can explain by entropy. Enthalpy means systematic changes from low temperature to high temperature, and absorptions are explained by the enthalpy. Entropy is also energy phenomenon. This will be explained by random molecules and whatever the random system of the conditions it will be explained. So, easy of desorption it will be takes place in the physical adsorption, whereas chemical adsorption the remove of the molecule not that much of easy because of chemical forces are involved. So, due to the chemical force are involved, that is a more strength it will be takes place. So, the best example of this material, powdered charcoal. Charcoal means coal powder. If the coal powder or coal material, if that hydrogen gas is deposited, that is physical adsorption. Charcoal paina hydrogen gas deposit అయింది అనుకోండి physical adsorption. అదే hydrogen gas ఒక నికెల్ ప్లేట్ కానివ్వండి లేదా పల్లాడియం ఆర్ ప్లాటినం ప్లేట్ పైన డిపాజిట్ అయింది అనుకోండి, దట్ ఈస్ నోన్ యాజ్ కెమికల్ అడ్సార్ప్షన్. సో డ్యూ టు ద కెమికల్ ఫోర్స్ ఆర్ ఇన్వాల్వ్డ్ ఇన్ దట్ పర్టికులర్ మెటీరియల్స్. నెక్స్ట్ అనదర్ వన్ ఈస్ depending on the nature of the adsorbent and adsorbate. Depending on the adsorbate, that is only for gases, easy liquefiable gases are more readily absorbed, depends on the adsorbate as well as adsorbent. No correlation can be given. So, here deposition rate means gases are several gases will be there, readily liquefiable gases will having the more deposition it will be takes place, and remaining particles deposition will be less. So, that phenomenon is called as what about the exothermic phenomenon. The delta H value and the delta S value is also belongs to negative phenomenon, it will be takes place. Another one is this energy explanations and energy phenomenon is explained by what about the Gibbs free energy. According to Gibbs free energy, delta G is equal to delta H minus T into delta S. Delta G is equal to delta H minus T into delta S, where delta G indicating as Gibbs free energy, H indicating as enthalpy, S indicating as entropy. Now, here you can observe adsorption is accompanied by the decreasing enthalpy and entropy. Adsorption is accompanied by decreasing of enthalpy and entropy, because of energy will be absorption will be takes place on the surface energy. So, due to that reason delta H value and delta S values are decreases, but adsorption process is a spontaneous process, it is a thermodynamical we can explain by the delta G is also negative condition it will be takes place. According to thermodynamic explanation, delta G is equal to delta H minus T into delta S, where delta H can be negative if delta H is sufficiently having the negative values of minus T into delta S is also positive condition it will be takes place. So, H is enthalpy, T is absolute temperature and S means entropy condition it will be takes place. Next, the extent of adsorption, another one is what over the influencing factors of adsorption. Influencing factors of adsorption. What are the influencing factors of adsorption? First influencing factor is surface area of the adsorbent. Surface area of the adsorbent. What is meant by adsorbent? Adsorbent is either solid or liquid. ఇంతకుముందే మనం ఒక వర్డ్ యూజ్ చేసాం adsorbent. Adsorbent belongs to either solid or liquid materials act as adsorbents. Adsorbate materials are either gases or liquids or solid particles are adsorbates. Now, factors influencing the adsorption. Factors influencing the adsorption. Adsorption influence చేసేటువంటి factors. Adsorption influence చేసే factors are what about the number one is nature or what about the surface area of the adsorbent. Surface area of the adsorbent. If surface area of the adsorbent is more, surface area of the adsorbent, so one adsorbent is like this and another adsorbent surface area is like this. One adsorbent surface area, this is first adsorbent surface area, this one is second adsorbent surface area. In these two adsorbent surface areas, which surface area will having more amount of materials are deposited, either gas or liquid, because of if the surface area is more, if the surface area is the more amount of particles are deposited. If surface area is more, adsorption rate is more. If surface area is less, adsorption is less. Surface area is more, adsorption is more. Surface area is less, adsorption is also less. So, based on that thing, what we have to do, the increasing of the adsorption or what about this decreasing phenomena based on the surface area. Next, another one is finely divided transition metals like what about the D block elements, cobalt, nickel, platinum act as a good adsorbents. Greater the surface area, greater extent of adsorption. If porous materials or silica materials are present, it's also greater of the materials or adsorption it will be takes place. So, one of the influencing factor of what about the surface area. Another one is nature of gas. Nature of gas means now the first phenomenon is based on the adsorbent, second phenomenon is based on the adsorbate. Adsorbate based on the adsorbate if gases, if I am taking gases. If the gases are readily liquefiable gases are there. Readily liquefiable means if any material, readily liquefiable gases material means the carbon dioxide gas, sulfur dioxide gas, ammonia gas, HCl gas, oxygen gas and nitrogen gas are there. Those readily liquefiable gases are readily deposited on the surface area. It's more adsorption phenomenon it will be takes place. If any gas will be having the whatever the liquefaction capacity is less, that adsorption phenomenon is also less. So, based on the nature of gases also the adsorption phenomenon is takes place. Another one is which contains low boiling point conditions. Now, that is another one is influencing factor based on the surface area. Another influencing factor is nature of the gas, that is called as adsorbent. Another one is pressure of the gas. If pressure will be increases, automatically adsorption phenomenon is also increases. So, based on the pressure factor, the influencing factor is one is temperature factor, one is pressure factor, another one is surface area, another one is nature of the gases material, that is called nature of the adsorbate. So, liquefiable gases, non-liquefiable gases it will be there, and pressure, if you are increasing the more pressure, the adsorption phenomenon is also increased. Based on the pressure application, two theorems are there, or two theories are there. One is Freundlich adsorption isotherm, another one is Langmuir adsorption isotherm is there. So, this is now once again I will give the brief review. What we are discussed today topic is, first one is surface chemistry deals with only the phenomenon of the molecules which are deposited on the surface area, and those surface materials by deposition how the physical and chemical properties are changes, that we are discussing. And for this phenomena terms are there: adsorption depends on factors are adsorbate, another one is adsorbent. Adsorbent materials are solid or liquid, adsorbate materials are gas or liquid or solid material. Another phenomenon is absorption, and absorption means that will be enters into the inner body of the material. And another one is sorption. Sorption means adsorption takes place via absorption. It's called as sorption. And another one is desorption. It will be takes place removal of the surface particles on the surface area of the what are the deposited materials, that is known as desorption. And another one is sorption and desorption. It will be takes place after the desorption, that is the adsorption phenomenon are influencing factors are three types. It will be takes place. What is physical adsorption properties and chemical adsorption. Physical adsorption will having the different type of parameters are there, that is based on the temperature parameter, next pressure parameters, enthalpy, entropy, and what about this activation energy, next desorption energy, nature of the materials. After that, the deposition rate will be having negative term, it will be takes place, that is based on the entropy phenomenon. So, the continuation we will discuss into the next class. Now that physical adsorptions and chemical adsorption, the physical adsorption, whatever the deriving theorems that will be there, one is Freundlich adsorption isotherm, another one is Langmuir adsorption isotherm, that will be discussed in the next class. And remaining, do you have what about the topic, and open your different type volumes. That volume belongs to in the second year, second volume is there. In the second volume, the topic and what are the topic today we are discussing on that topic, and open that book, and module 1, module 2 will have in the different type of questions are there, and have to read once again and do the different type of questions accordingly. In that questions, do you feel any difficulty or any what about the question you are not understanding for that, and only this topic only what we are today the discussed on that topic only you give the what about the answer. In that, do you feel any difficulty, you post the questions in your group, and our team will be give the answers. Next, in that, in your volume 2 will having page number, if you open that in your volumes, in that volume volume 2, the page number will having the page number 64, it will be there. In that 64 volume, the first one of the question will be there, which of the following gases adsorb more, which of the following gases is adsorbed more, it will be there. And that question, the options are hydrogen, nitrogen, oxygen and ammonia. These are the gases are there. In these gases, which gas will readily adsorb more? This is first option, this one is second option, this one is third option, this one is fourth option. In these four options, which option is correct? Now, that one concept is there, adsorption influencing parameters. Adsorption influencing parameters are readily liquefiable gas are more adsorbed more easily. The readily liquefiable gas is ammonia. So, in that the gas which are belongs to, what about this hydrogen bondings, it will be takes place, and more attraction force it will be takes place in between the two materials, those are readily liquefiable gases, it will be takes place. Another one is, one question is there, finely divided substance is more effective adsorption because, finely divided will having that more attractive, because in that what I am discussing the questions are volume 2 and page number 64, and that adsorption bits, the question is, sixth question is there in your modules. In that sixth question will having the finely divided substance is more effective adsorbent, more effective adsorbent because, and what is the parameters are means one options are there, large surface area, low surface area, more liquefying nature, less liquefying nature. Finely divided means if the materials are in the powdered form, it will be takes place, that is having, what about this easily powdered materials are called as finely divided materials. The finely divided materials are large surface area, it will be takes place. When large surface area is there, automatically those materials are readily deposited on the surface area. So, that phenomenon is called as, what about the adsorption phenomenon. Next, next another one is activated charcoals and in chemical reaction solid catalyst functions. Generally, the catalytic function will be takes place, more active catalysts are, that one is nickel, palladium, platinum metals are there. The nickel, palladium, platinum metals will having the more activated materials. So, in that hydrogenation of oils, in that earlier we are discussion on the surface area will having the interstitial places will be there. In that interstitial places, those gases materials are deposited. Now, this molecule of the surface area, in that if you are passing that hydrogen gas on the surface area, that hydrogen gas will be deposited on the interstitial places. When it will be interstitial places, automatically the bonding is called as, what type of bonding it will be takes place, that is chemical adsorption is takes place. Due to the chemical adsorption, the strength will be more. And if you same the gas is passed on the solid surface, that is activated charcoal. Activated charcoal means that powdered charcoal, if you are that hydrogen gas, if you are passing, those gas materials are deposited on the surface area. The gas materials are deposited on surface area. There is no chemical bonding takes place in between adsorbent and adsorbate. So, due to that reason, by heating the materials, if you are applying some temperature here, the gas particles are easily escaped out, but whereas here the gas particles will not escape out that much of easily. So, that is what about the chemical adsorption phenomenon, the strong strength it will be takes place, whereas physical adsorption phenomenon will have in the less strength it will be takes place. So, that is the reason, if the surface area is more amount of materials are deposited, surface area is less amount of materials are deposited. And another phenomena is readily liquefiable gases and non-liquefiable. Now, if you are observing here that four options, hydrogen, nitrogen, oxygen and ammonia, that ammonia will having, it will be takes place hydrogen bonds. So, due to the formation of the hydrogen bonds, the materials are readily liquefiable, but whereas hydrogen, nitrogen, oxygen, there is no hydrogen bond formation, it will be takes place. So, those gases are called as non-liquefiable gases. Non-liquefiable gases deposition rate is less, liquefiable gases deposition rate is more. So, in that entrance level, you have to focus on these two areas. One area is adsorbent area and adsorbate area. Adsorbate materials are gases, liquids, solids, and adsorbent materials are solid and liquid. And this phenomenon is called as adsorption. This phenomenon is called as adsorption. So, that is what about this here, the phenomenon center. And these are the effective factors and effective materials are there in that in your module, different type of questions are there. So, which catalyst we are using means generally metal catalysts are we are using. The metal catalysts are, that is D block elements, The D block elements are nickel, palladium, platinum materials. Not only nickel, palladium, copper, silver, iron materials also acting as a good catalytic property. Catalytic property means enhancing of the strength of the materials are called as catalytic material. And another one is, if we are seeing that one more question on the surface layer of the solid means, the surface layer of the solid, how it will be takes place. The surface area of the solid, it will take place only 100 nanometers depth it will be takes place, because of the surface area will having that more surface area, more deposition, and after the deposition where it will be takes place means 100 nanometers depth it will be takes place. This is the question asking the different type of entrance level of the examinations. And tomorrow we will discuss about the influencing factors, and another one is what about this pressure factors, pressure factor derivation factors are there, that will be discussed in the next class. Thank you.